So the first thing we're going to try and tackle here when it comes to doing a rotation, okay, is doing a rotation kind of like just in space, okay, or on a plane, I guess I'll say, okay. So this kind of rotation, right, there's no real coordinates or anything like that. It's just kind of like in a plane, on a flat surface. All right, so first of all, let's review rotation, right? So a rotation is a transformation around point P. So I get that. Ugh, it's like way knocked down. There we go. Okay, a rotation is a transformation around point P, the center of rotation, such that the following is true. Every point and its image are the same distance from P. Okay? All angles with vertex P formed by a point and its image have the same measure. Okay, this angle measure is the angle of rotation. So as a picture here, and this is kind of hard, I don't know, it's like poorly organized here, but like this diagram goes with, it says in the figure the center of rotation is point P and the angle of rotation is 110, and that's like the figure's down here. I feel like that's not really well laid out, but anyway. So here, okay, what they mean by that is, so here's a rotation, right? We can see, right? It's indicated by that little curvy arrow there, okay? Point A, right, is rotated about point P, so point P is the center of rotation. It's rotated about point P, 110 degrees, to A prime. Okay? Let me see here, what else I want to say there. A is the same distance to point P as A prime is, right? And the angle formed between A and A prime, right there, is 110 degrees. So that's like what we call the angle of rotation. Okay. Now, when we rotate, there's two different directions you can turn, right? You can turn clockwise or you can turn counterclockwise. All right. Here, we're not specified. It's not told, or we're not specified. It's not specified. Sorry, what direction we're rotating. Okay. And so, what direction did we end up rotating, though? According to this picture, what direction do we end up rotating? How would we describe this direction? Counterclockwise or anti-clockwise if you're British, right? So that's exactly right. And if it's not specified, okay, if it's not specified 110 degrees, like which direction, then we assume counterclockwise, okay? So if the direction of rotation is not specified, okay, assume it is counterclockwise. I'm going to, write that out. Okay, and we will abbreviate counterclockwise as CCW. Okay, not Creedence Clearwater, counterclockwise. Okay, all right. So that's the idea there. All right. So in letter A, okay, it asks us to actually do a counterclockwise rotation of 150 degrees around point P. Okay, and here's how we're going to do that. All right. The first thing we're going to do is rotate, or come up with like a segment here, and then draw our angle in. Okay. Now again, since we're working with these protractors, and it can get kind of frustrating working with these books because you have to like keep them super flat and stuff like that. If you want to tear your page out to work on it, okay, we're going to be working up through, well, I would say at least up through maybe 93. So if you want to tear out through 93, and that'll also have some of the homework on it potentially there, but yeah. So at least 88 to 93, and then I'll get to the homework as well. If you want to tear them out, just to help you, okay? If you don't like the idea of tearing it out because you're afraid you'll lose papers or something, I understand, but it might not be a bad idea. Okay, I'm going to soldier on and keep my papers in my book because I don't know, I don't have a reason. All right. So in the meantime, once you're done tearing those pages out, I'm going to put some points here. Like more obvious points, okay, on my vertices, the triangle ABC, and then we're going to draw a segment from P to any of the points A, B, or C. I always draw my segment to the point that is closest to my center of rotation. So in this case, that's A. It's kind of up to you. Okay, but I'm drawing a segment there from P to A. Okay, this segment that I drew is going to be one side of my angle of rotation. Okay, and so now that I have this one side of my angle, I got to come up with the other side so that I have a 150-degree angle, and that's where we're going to use the protractor, right? So we're going to set our protractor down here on the side of my angle. Okay, line it up real good. And then I need to measure a 150-degree angle. So on my protractor here, right, I have two sets of numbers. Which set of numbers should I use? The inside set or the outside set? Yeah, the inside set, okay? So I'm going to measure here to 150 and put a little mark. And then I'm going to go ahead and draw a segment or array, whatever you want to say there. Through like that. So now I have a 150-degree angle counterclockwise. But now we need to measure A, B, we need to get A, B, and C, the whole triangle there, to rotate around. And how are we going to do that? Well, that's what we're going to use our white piece of paper for. Now, ordinarily, I have nicer paper. I have this like patty paper, and it's called patty paper because it's the paper that's used to put between hamburger patties. You guys use this in the reflections, okay? So unfortunately, I am now out of patty paper, so I have to get some more. But it's nice because it's thin.
Protractors and rulers are so great.
Yeah,
You're never going to need to go get more of them.
Rulers are lame.
I just said to my kids, we're not an origami class. We're not going to use patty.
All right, whatever. They probably don't know what patty paper is. Anyway, so we're going to use printer paper, and I think it should still be dark enough. Yes, it is. Okay, so it should still be dark enough. And actually, what you want to use here is a pencil. If you're using a pen right now, you're going to want to use a pencil. I got to get a pencil. Okay. What you're going to do is you're going to trace your point P, okay, and we're also going to trace the vertices of our triangle, so that's going to be A, B, and C. And you also need to trace the segment that you drew from P to A there, okay, and you can't see this at all, but I can see it through mine at least, so. Is anyone having trouble seeing their lines through their paper? Okay, thank goodness. The paper is just thin enough that we can see through it. Okay, so there's my like traced out version there. Okay? Now, we've got that nice and traced out, right? And I just would then, well, what do I need to do? I need to rotate it, right? So I'm going to rotate around point P. Sometimes if you hold your pencil point on the point of rotation and you turn your paper, sometimes it will stay in place. And mine didn't do too bad of a job there. Okay, and so there it is. There's where the triangle would rotate to. Once you line up your segment, okay, keep point P on point P, right, and rotate around that, and once you line up the segment to the other side, now you can see where the triangle needs to rotate to. The problem is, how do we get these triangle vertices to our paper? All right, and what we can do is we actually need to pick our paper up here real quick, flip it over, and draw on the backs of the triangle vertices. So color in the backs of those triangle points, and then flip your paper back over to its original side, okay, and complete that rotation once more, so that point P is still on point P and that your segment's lined up, and then draw on those points, the front side of the points, the ones we initially drew. And if you do that, the backs will transfer over, and you can see these light little dots. Now that is your rotation. And you can connect the dots using a straight edge. And voila, we rotated 150 degrees. Now, because we just did a transformation, we should probably also label these points, right? So let's see here. So Maria, what would I name this point right here? A prime, very good, because it's transformed, right? It rotated from A. So there's A prime. And what would this point be right here, Maria? Ooh, it would not be C prime.
Wait, where does C prime?
It would be rotated from around here to here. So what is this one right here?
B prime.
Yeah, B prime. And that leaves the last one there to be C prime. Okay, so there's that rotated triangle. All right, questions on any of that? That's the idea there for the rotation. Okay, so let's try another one here. Let's try another one. All right, so let's go here to B. Okay, and so for letter B, we're going to do a clockwise rotation. Clockwise rotation of 75 degrees around point Q. Okay. So, is this it? Yeah. Okay. So, same thing here, right? We're going to take, put some vertices down for E, F, and D, or D, E, and F, and then draw the segment there from Q to D. All right, I'm going to measure my 75 degrees. I'm going to put my protractor down right there, right? Yeah, I got to put it on the other side, don't I? Because I want to do a 75-degree rotation clockwise, okay? If I put my protractor here, the only way I can do my angle is from here and then around, and that is a counterclockwise direction if I go this way, okay? I want to go clockwise. It means I have to put my protractor here, which is kind of weird, and if this makes you uncomfortable, turn your book, okay, or turn your paper so that maybe it's oriented a little more normally for you, okay? All right, so here's the side of my angle right here, from my point of rotation to point D. And so if I'm using this as one side of my angle and I want to open up 75 degrees, which set of numbers am I going to use? The outer set of numbers or the inner set of numbers? The outer set, okay? This is one side. It should start at 0. And I'm going to count all the way out to 75. So there's 70 right there, and 75 is halfway between 80 and 70, right? So there's 75. And so then we'll draw. Okay. And there's our angle of rotation. 75 degrees clockwise. Okay. And then you take your paper. So any questions thus far? Any questions thus far? Okay. And I like to be I'm very frugal with my paper. I like to reuse it a lot here. So I scratch out my old work, and then I just kind of use the next little bit of white space beneath it. In fact, I can even do it like this maybe. Okay. So I'm just going to fit in my white space here, and I'm just going to recopy point Q, and then recopy points D, E, and F. And if you want to label D, E, and F on your paper there, that's okay. And then don't forget to also draw the segment that you drew from Q to D as well, like so. Okay, let's get that right. Hook right. Okay, so there it is, copied. It's much easier to see when I use the patty paper, but you get the idea there. Okay, and we're going to rotate that to 75 degrees clockwise. Again, if you want to use your pencil point, you can poke into point Q there, and then just, let's see if I can get my hand out of the way, and then just rotate it on down, and it pretty much matches up. Let me see here. Okay. I think that's lined up for the most part. Something like that. Okay. But again, you can't transfer, so don't forget to draw on the backs of your points. Draw on the backs of those points. And yes, you'll end up accidentally transferring some of your points. Erase that away or something. Okay, so then just line it up and copy it down. So D, E, and F. Boom. And then connect the dots. Okay. Now if you want, you can erase away some of this like ray that you did to help you rotate it, just to make it look a little bit neater. And then relabel your points: D prime, E prime, F prime. Okay. And there it is. Okay. And there it is. There's what it should look like. Not too shabby. Any questions on any of that? Alright. So I want to see you guys try and do one here. Let's have you do a... Let's see. You can do either 4 or 5 on the next page. So go ahead and flip over and pick just one of those to do if you'd like. 4 or 5 on the next page to see if you can do it all on your own. I will do them both real quick, and then I'll come around and help if necessary. And What's that? Trying a different way?
Yeah.
Okay. Okay, so 40 degrees counterclockwise. Keep it whichever one you want, but just make sure you're consistent. You're right. Mason, that's done. That's still working. What's the matter? So you're having some trouble with that, or? So let's see. Alright, so is this supposed to go like that then, right? Wait a minute. Like this. No, actually, hang on. This is the one? Oh, okay, third, okay. That's that, okay, so you gotta draw on the backs of these then. So just on the backs, just draw on the backs of the points. That's draw on the backs there. I'll show you, draw on the backs, and I'll show you. Okay, so now we put it back over, okay, and so we put it in that, okay, and we're going to rotate around point P. So point P needs to stay stationary, and just rotate it, keeping point P on there, and then you can stop right there, because now you're not the other, you rotate it to the end. Now you just draw on those points. Okay, and that's what transfers it through. Okay, looks good. Yeah. Where's your agenda? We lost it.
Do it again, Hunter.
It's right, they're only $5, so.
Okay, that's fine. That's good, okay. It's pretty good. The only thing I'm gonna say is, I see that this and this, it got closer to point P. Should that happen, it's rotating around? No. So which one of these did you use? This one. So when you're doing it, it should stay, it should stay on point P. Okay? Looks good. Okay? Not quite, no. So where is it on here? This, okay. So here's what you so here's the problem. When you rotate, it should stay the same distance from point P. Clearly that didn't happen, right? So what happened? So
Is this like?
wait, what's this one? Was this one?
Yeah.
This one. Okay, that's it, maybe?
Is.
I understand. So that's why I would suggest, like here, when I push here, make those really dark. So you see those points. Here's the paper. So right there, that. And the house it. Like that. Okay? We draw the backs of our triangle. And you rotate so that it's still on point P, but line up with the angle. I'm assuming that's the 40 degree angle marker, okay? So, and there's where your point should end up. There they are. Okay?
Thank you.
Mm-hmm. Okay. Here we go. Let's take a look here. Boom. That's what you should have gotten. Blank space. Nope, wait. There you go. That's what you should have gotten. Okay? There's 4 and 5. Alright. Make sure you're getting the correct directions too, okay? Super important. Counterclockwise for the first one, clockwise for the second one. Okay? So there we go. Now, we've all done these kind of rotations here, no big deal, right? 40 degrees, 125 degrees. Well, what if I asked you guys, though, to do a rotation of like 210 degrees counterclockwise? Can we use this method if we want to do a rotation of 210 degrees counterclockwise? What's a problem we're going to run into? Yeah.
Way number
Okay? So if we want to rotate 210 degrees, what's the problem we're going to run into? Right, so the protractor only goes to 180 degrees. So we're kind of in trouble, right? If I want to rotate something about a point, let's say I got, here's point P, I want to take point A, I want to rotate that 210 degrees counterclockwise. I can't do that using my protractor because it only goes up to 180. Or can we? What's an option we have here? So how'd you know it was going to be 150 clockwise? Right, okay, so the whole way around the circle here is 360 degrees. Right? If we're trying to go 210 counterclockwise, well then certainly there's a shorter way around clockwise. And in fact, yeah, 360 take away the 210 leaves us with 150 degrees. Okay? So we can do all sorts of angles that we didn't maybe think were possible with our protractors. Okay? We just sometimes have to find the opposite of it. Too bad there's not a name for two angles that add to 360 degrees. Maybe there is, and I just don't know it. Okay, but anyway, we can find the other angle here. So instead of the 210 degrees, we do the 150. Is that what you're going to say, Zishan, by the way? Okay. Kind of like that, but same idea, right? Mm-hmm. Good. Very good. Okay, so now that we've talked about that, we're going to look at drawing rotations on the coordinate plane. Okay, so just like for reflections and translations, okay, we have some rules here that we can use. These are the coordinate notations that match up with these kind of rotations. So for example, a 90-degree rotation counterclockwise takes a point XY, flips it, but it does the opposite of whatever the old Y coordinate was. Okay, a 180-degree rotation keeps them the same, but it makes them both opposites. 270-degree rotation counterclockwise is XY, flips them again, but now it's just the X that's the opposite. And then 360-degree rotation takes XY to XY. It's like, I don't even know why they put this one in here, because what does a 360 rotation do? It goes back to itself. So it's like, duh, it goes back to itself. Okay, I don't know why we even need to have that written there, but there it is. Okay. Seems kind of silly. These will not be given to you on the test. So if you want to memorize them, you're more than welcome to. But you can also use this tracing kind of construction thing that we've done to do these rotations as well. Okay, so either one. Okay, if you look here, for example, they took quadrilateral ABCD, they want to rotate it 270 degrees. Notice there's no direction given to us, so we assume the direction is counterclockwise, okay? So they're going to then use this coordinate notation here from the table. If we're doing a 270-degree counterclockwise rotation, that is this one, xy to y negative x. And you can see that 0, 2 flips, right, becomes 2, 0. Okay? Since the y coordinate here was, for this transformation, the x coordinate flips to the y coordinate and it becomes the opposite, but the opposite of 0 is still 0. Okay, 1, 4 flips, and again the old x coordinate becomes the opposite, negative 1. So it's 4, negative 1. Again, flip, and the old x coordinate becomes negative 4, and then flip, the old x coordinate becomes negative 3. There. Okay, so those are the new points. All right, and you can see then in the picture up here when they plot a prime, b prime, c prime, d prime. Okay, you can see that A, B, C, D has maybe rotated there around to A prime, B prime, C prime, D prime. And we can actually identify the angle of rotation there if we wanted to as well. We can kind of like check it out. So for example, if I take A prime, okay, and go to by the way, what's the point of rotation here? What are we rotating around? Yeah, 0, 0. There's our point of rotation. And so if I make a little segment that goes from 0, or the origin to A prime, and I do a little segment from A to the origin, what kind of angle do we have right here? Well, I'm going to go ahead and write it in. It's a right angle, okay? It's 90 degrees. Okay? So that means that this is 90 degrees. What's this counterclockwise rotation? There? 270, which is what we were supposed to have found. Okay, so here again, this is just an example. They found, or the book found A prime, B prime, C prime, D prime using those coordinates, but in fact it did end up in a 270 degree rotation. Angle A prime is 270 degrees counterclockwise from angle A around the origin. Okay? So let's try this coordinate notation stuff here for letter B. Okay? The rotation image of xy is what? Well, what happens according to the table there? Okay? If we go back, let's see, I'll pick somebody here to say. So let's go, so Tanner, what would xy become here for a 180 degree rotation? Negative y. Oh, negative yx, that's not for 180, this is for 180 degrees. There you go, negative x, negative y. In fact, maybe I should give this in different colors so it stands out a bit more. Yeah, negative x, negative y. Okay, so that means that Tanner 2, negative 1 becomes what? There you go, negative 2, positive 1, right? Okay, and let's see here. That means that, man, I keep getting the same names, I feel like. So, Evan, how about 4, negative 1? What does that become?
4 under 1, that would be negative 4, 1.
1, good. And then, Melissa, what about 1, negative 4? What does that become? Negative 1, 4. Very good. Okay. Now the next sentence here says, predict the quadrant in which the image will lie. Since triangle KLM lies in quadrant, what, Melissa? What quadrant is KLM in? 4, very good. And when we write quadrant numbers, we normally write quadrant numbers in Roman numerals. Okay. Lindsay, where do you expect then, if the triangle is going to rotate 180 degrees, what quadrant do you expect it to end up in? Quadrant 2. Okay, and so let's actually plot K prime, L prime, M prime to graph the image. So negative 2, 1, that's K prime. Negative 4, 1, that's L prime. And then M prime is negative 1, 4. And then connect the dots. Voila. Okay, 180 degree rotation. Okay? You'll notice here that, again, we're not given a direction for the 180 degrees, okay, so we're not told if it's counterclockwise or clockwise, but does the direction matter for 180 degrees? Does the direction matter when you do 180 degrees? Yeah, no, because either way it's going to end up in the same spot, because 180 degrees clockwise is the same as 180 degrees counterclockwise, so. Okay. Now here's an interesting one. Number 6, let's try and figure out this one. So 6 says, suppose you rotate quadrilateral ABCD. That's the one from here, the top of the page. Okay, so that, by the way, ABCD is in what quadrant? Anybody?
1.
Quadrant 1. Okay. Suppose you rotate quadrilateral ABC in part A by 810 degrees. In which quadrant will the image lie? Explain. So, any ideas here about how you could figure that out, besides, actually doing 810 degrees? What can we maybe do to help us out? Yeah, Hunter?
You could keep on subtracting 360.
Why can we subtract those 360s?
Because 360 would just make it go back to the same.
Okay, so let's try subtracting 300. So let's do 810 minus a 360. Okay, what does that end up with?
I can't do it in my head.
Is it 450? Evan? 450? Okay. All right, can we subtract another 360 here? Yeah, we got another 360 we can subtract off. Okay, so we get 90. And so rotating 810 degrees is really just like rotating how much? Just like 90, exactly right. So if we go look over here, if we're rotating this 90 degrees, and by the way, since we're not specifying a direction, we're going to assume counterclockwise, so what quadrant will this end up in? Yeah, quadrant 2. Quadrant 2. Because rotating by 810 degrees is like rotating by 90 degrees. Okay, that's actually something that I teach in pre-calculus, or used to teach when I taught pre-calculus. That's something we teach in pre-calculus. Okay, 810 degrees and 90 degrees are called coterminal angles. okay, are coterminal angles. Okay, and again, why do we call them coterminal? Well, the meaning is right there in the word. Co means to share, and terminal, well, terminal means to end, right? But sometimes terminal also means to start. For example, when you go to the airport, right, what do you go to get on your flight, get on the plane? You go to the terminal, right? The terminal is where you go to get on the plane to start your journey, but the terminal is also where you get off your plane when you end your journey, right? Or when you go to a train station, sometimes a train station is also called a terminal, because you both start and stop journeys there, right? So a co-terminal means you're sharing the starting and stopping point. That these angles, 810 and 90 degrees, both share the same starting point and stopping point as one another. Okay? Neat. English. Okay. I'm gonna hold off on having you guys practice here. I think we're gonna be okay with that for right now, but instead what I want you to do is do one more thing, and that is determining the angle of rotation. Okay? So we're gonna look here, and you kind of get some hints there, but
Teachers, pardon this announcement, please. Unified tennis participants, please come to the front of the building. Unified tennis, please come to the front of the building.
is anybody here? No? So let's take a look then at letter A. Okay, so example 3 says, find the angle of rotation and direction of rotation in the given figure. Point P is the center of rotation. So ideas here. What can we maybe do to find this angle of rotation? Evan?
Well, you could either point B or point A.
Okay, or really C or D. Those would be okay too. But okay, pick a point then. Let's go ahead and do that.
Let's just go with point A.
So, okay.
Connect those points to point P.
Okay, so P to A.
Yeah, and then P to A prime.
And P to A prime, because A prime is the image of A under the rotation. Okay.
And then you want to make sure you are that the angle is acute because it's 90 degrees.
Yep, you can clearly see it's an acute angle, and so we're going to use our protractor then and just measure that, right? And that's it. That's all there is to it. Okay? If you go to measure your angle and you realize that, I can't really tell what this is because my side's not long enough, feel free to extend through, like A prime, for example, if you need to, okay, to get that angle right. And I maybe didn't do a great job there, but okay. So it looks like, what does that look like? What does it look like our measure is? Maybe you guys can see it there. Okay. What does it look like our measure is for the rotation? 80. And what direction is that? Clockwise or counterclockwise? Counter. CCW. Okay. Okay, so yeah, it's that simple. Okay, I'm not going to have you guys practice that. We're all not going to practice it on your own here. We'll just have you start on homework, okay? So there's that. Pretty straightforward. The biggest key here, right, is that make sure at whatever point you pick over here, you draw to point P, and then you draw from point P to its image. So if Evan had chosen B to P, he better draw from P to B prime, okay? Otherwise you will not get the correct angle there. All right, so for your assignment, here's what I would like you to do. All right. So I would like you to do numbers 2, 3, 4, 5, and 6. Okay, again, this is on page 95. So 2, 3, 4, 5, and 6. Let's see here. Nah, that's okay. 9, 10, 11, and 12. Now, let me get you guys a little hint here for 11 and 12. What they're asking for when they say write the algebraic rule, that means coordinate notation. So, for example, I want you to show me, kind of fill in the blanks here. Okay, X, Y, arrow, and then you're going to fill in those blanks. Okay, I'll give you a hint. It'll be helpful if you list out G, well, I'm going in a weird order here, G, E, G, F, E, D, okay, and then you list out G prime, F prime, E prime, and D prime, okay. If you list out all their coordinates, it will help you figure out what the rule is. Okay, that's just a little hint to help you get started there with that one. And then let's see, I wanted you to do any more. No, no, no. Yeah, I'm gonna have you take one more here, okay? So I'll tear out the next page too. Oop, and that's like actually tearing. I didn't mean to do that along the perforation there. Okay. All right, so I want you to try 14. And then, in honor of the fair, I want you to do number 17.
Can you just repeat all of them?
Yep, I'll do it one more time here. I'll write up on the board actually. So let me turn off the video.